Welcome, Calc students. This is Calculus CP. We are looking at a new technique for derivatives. It's 3.6. A couple of distractions. We may have a bell from the school going to be going off once in a while. I got the mower in the background, so we'll see if we can fight through all the distractions here. But we're going to go ahead and give a short little video, maybe 6 to 8 minutes on the first method of the chain rule. So the chain rule is a method for derivatives. I'm going to first start out with comparing what makes it the chain rule versus why it would not be the chain rule. Okay, so the first example here I have y equals 3x squared minus 2x. That is not the chain rule. You can just go ahead and take the derivative, no problem. The next one, this is the chain rule. All right, I'm going to come back to the reason why after I show all of them. The next example, I have y equals x plus 2. You can take the derivative, no problem. However, if I have the square root of x plus 2, I have to use the chain rule. The third example, if I have a trig function, the first one here is 3x squared times sine x. That's not the chain rule. That's the product rule. You got two things being multiplied. However, the next one is sine 3x squared. That is the chain rule. So what makes a chain rule? When you have a composition of functions. For example, the first one up here, I have this inside function, the 3x squared minus 2x. That whole thing is being raised to the fourth power. The second one is x plus 2. That's the inside, and what's outside is the square root. And then finally, the trig function. Inside the trig function is this 3x squared. The outside function is sine. Unlike the original over here, they are two separate. They have to do the product rule, two different things. So it's an inside and an outside, thus the composition of functions. So moving on down here, I have the U substitution method for the chain rule. And if we just state that dy over dx, that's your derivative, can equal dy over du times du over dx. So what it's introducing is a third variable, u, and it's called the U substitution method. Best way to explain it is do some examples, and I'll do all three examples right now. Y equals 3x minus 4 raised to the 6th power. Well, first you identify u, and u is the inside part, which is 3x minus 4, which then it's really y equals u to the 6th. Now we have to take the derivative of this u with respect to x, so therefore we write du over dx, and that derivative is a 3. We have to take the derivative of our y with respect to u, so we write dy over du equals, and that would be 6u raised to the 5th. And according to the chain rule, and we just rewrite the chain rule from above, it is dy over dx times dy over du times du over dx. Okay, so if I want to find dy over dx, then I just simply multiply dy over du is 6u to the 5th times du over dx is a 3. And I get 18u to the 5th. Now that's great, however, I don't want the u there. I want dy over dx. I have a u in there, so I got to make my substitute. My last step is to make a substitution, and it is 18. What is my u? Let me go back here. Oh, my u is this. It's 3x minus 4. So I replace that, 3x minus 4, and that is the derivative. So I would just write down y prime equals 18, 3x minus 4 raised to the 5th. Okay, let me do the next example. Here you have a square root. I think I'm just going to rewrite this quickly as 5x squared plus 4x raised to the 1/2. All right, so you take your radicals and you're going to rewrite it exponentially with an exponent of a 1/2. So my inside function is the u. In that, I'll just label that right here. It's going to be 5x squared plus 4x. And then my y must be u to the 1/2. Take the derivative of both, which is du over dx. That's going to be a 10x plus 4. And of course, take the derivative of y with respect to u, which is 1/2 u to the negative a half. Subtract 1 from the exponent, negative a half. And then, of course, you multiply these two together to find dy over dx. I get 1/2 u raised to the negative 1/2 half, and then 10x plus 4. You're going to need to put parentheses around that because there is two terms and it is being multiplied. That quantity, that term, is being multiplied, so you need parentheses. Now, of course, we got to clean it up. I guess I'll do it the long way here. 1/2, and my u is 5x squared plus 4x raised to the negative 1/2 times 10x plus 4. You may see answers such as this. Because it's negative 1/2, I can write that on the bottom. So send it down below. 5x squared plus 4x raised to the 1/2 on the bottom. I am left with a 1/2 times 10x plus 4 on top. Well, you can distribute that 1/2. And that's going to be what? 5x plus 2. And you may not see that answer on some websites or wherever you try to find your answers from. You may see something like 5x plus 2 divided by the square root. That 1/2, you can rewrite it as a radical. Just to let you know, you can rewrite it back to a radical form. And then, of course, you may even see answers where they rationalize it and so forth. But I'm happy with those types of answers. I do want to see you simplify those two terms right there. You can't distribute the 1/2 into here. That's not possible because of the exponent. Okay, let's do another one, a trig function. Okay, so you got to identify your inside function, and of course it's going to be 7x plus 1. I might just take the derivative right away. Du dx is 7. I will go ahead and make that substitution, sine u, and the derivative of that with respect to u would be cosine u. You just go ahead and multiply those two together. Cosine u times 7. I would put the constant out in front, cosine, and what's my u? Oh, it's 7x plus 1. And that is the chain rule. That concludes this video. I'm going to pick it up the next video, the second method called the outside in. I have a different terminology for it, but we're going to begin at the next video right here.